All right, I think we're live, hopefully. Yep. I'm watching my YouTube studio right now. I can see the stream sort of firing up. I did one stream last week, my first stream ever, and now I'm trying another one. So hopefully now I kind of know what I'm doing. We'll see if anyone shows up. Yeah, last time we had, I don't know, about 20 people at one point. That was kind of cool. So we'll see how this goes. I see 2 concurrent viewers. Yeah. We'll see if anyone has anything to say. The idea here is, hey, someone showed up. Yeah, the idea here is to just work on this game that I've been making. Hey, someone in chat says hi. I tried last time to make it so that you could see the chat replay later, like once this went up as a video. Hello, everybody in chat. I tried to make it so you could see the chat replay, but I couldn't figure out how. It looked like I had the setting on, but it didn't work. So I don't know. I'll try again this time. I know it's possible, but I don't know what I did wrong. Hopefully there's nothing I have to do right now to make it work. Anyway, we'll give people a couple more seconds, maybe a minute or two to roll in, and then we'll start working on this. But the idea here is I've got this game, this little sort of pendulum physics simulation, and I want to make it into kind of a fun, polished game. So that's the goal of this stream here. Yeah. If you're not familiar with pendulums, maybe we can talk about that. Yeah. Pendulums are kind of a physics thing. Like generally people talk about it when they're talking about physics. And it's basically where you just have like a ball on a string and you let it, or on maybe like a rod, and you just let it kind of hang and swing around. You might have seen like a grandfather clock will have a pendulum, and that's how it tells time. Yeah, we can look at the pendulum of a grandfather clock. So it has this little swinging thing down at the bottom, and it's kind of interesting. Hey everybody, they can actually use this to keep track of time. That's how they did it before, you know, all the electronics. Yeah, so Aqua, the idea here is I've got this pendulum physics simulation that I created, and the goal is to turn this into a game. So yeah, the way this works is you can see when I click the green flag, this pendulum sort of swings back and forth like it's being affected by gravity. But it's on this green cart. And the deal is I can actually control the cart using the arrow keys. So if I press the left and right arrow keys on my keyboard, like if I press right, the cart actually moves to the right. And if I press left, it goes left. And then the pendulum sort of swings. So I'm controlling the cart now. The pendulum sort of swings based on how you drive the cart, which is really cool. Yeah, so I spent a long time trying to get the physics to work, but it's really cool. The good thing about this stream is there's only a half-second delay. I think it's a little longer than that, but yeah, it's not too bad. So I actually put some comments in this code because there's, well, you can see there's kind of a lot going on here. I have an entire notebook where I just wrote out by hand. I found on Wikipedia, they have a little cart with a pendulum on it. And then they have the physics here. And right down here, they have 2 different equations that were really useful. And I was able to solve these to get the acceleration of the cart and the acceleration, like the angular acceleration of the pendulum. And once I did that, then I could implement all the physics. So we're not going to talk about the physics too much because, well, I don't know, it's kind of a lot. Hit something with the weight, that's kind of a cool idea. I have one idea that I think is really neat. If you go to the inverted pendulum page on Wikipedia, they talk about how people make these robots. So this is a balancing cart, which is a robotics system. And the idea is that the cart tries to drive itself to keep whatever is up top balanced, right? And so it's like an inverted pendulum where the pendulum is pointing up and you're trying to balance it, right? You can imagine having like a broom on your hand and you're trying to balance the broom upright, just kind of by moving your hand around. And so I thought, hey, that's a cool robotics project. What if we turn that into a game? And so what I've been trying to do for a while now is I will actually play with my physics simulation, and using the arrow keys, I try to sort of swing the pendulum and get it up to the top. Ooh, you can see I almost got it there, but not quite. You try to get it to balance right at the top. Yeah, it's actually really fun. So there we go. There we go. Look at that. I got it balanced at the top, and then you kind of gotta you gotta keep it balanced. And I've actually been practicing enough that I've gotten pretty good at this. You can see once you get it stable, you don't have to move a lot to keep it up top. So, you know, I'm making it look fairly easy right now, but it really isn't. Like, it really is pretty challenging, and I've just been practicing a lot. So I think the idea here is to make a game where you are trying to get this thing to balance up at the top for as long as possible. Yeah. So, the question is, how are we going to do that? And I think the first thing to do is just keep track of, you know, how long are you holding it at the top? So, well, first we need to have some kind of if statement that can check, like, whether or not the thing is currently balanced if it's at the top. So I have this variable theta that represents the angle, the current angle of the pendulum. So you can see as it swings back and forth, the angle theta changes. And when it's up at the top, we can see what happens to theta. When it's up at the top, theta is near 0, right? You can see it's like a small positive or a small negative number. And that means the pendulum is like balanced upright. So what we want to check is whether the angle theta is near 0. And so I will take, I think, the absolute value of theta, which is basically just says make theta be positive. So if you take the absolute value of 5, it's still just 5. But if you take the absolute value of -5, it also gives 5. So it sort of gives you the positive value of every number. So if you do the absolute value of theta, it'll make it positive no matter what. And then we can check, is it less than some amount? And so this will tell us if we're within maybe 45 degrees of upright. So I think, what am I going to do? I want to have some way of sort of visualizing whether or not you're currently balancing. So I think maybe I'll change the pendulum color when it's balanced, when it's up at the top. So here's where I'm setting the pen color to draw the pendulum. So we'll just say, maybe if it's balanced, then it becomes red or something. Yeah. All right, so let's try that out. So if it's up at the top, then it becomes, yeah, so if you're within 45 degrees, now you can see it doesn't work there. But if you're within 45 degrees of the top, the idea is that it's going to turn red. Yeah, because that's when you're balanced. The problem, though, is theta, if you watch that variable theta, it sort of keeps getting bigger if you rotate around in the same direction a bunch of times. That number can get bigger than 360. So you can see we already have a theta that's like in the thousands, which means, of course, that it's not less than 45. So I think I also want to use the mod block. And mod, I can say mod 360, which will basically say if it's more than 360, then loop it back around to be a small number again. And we'll see how that works. So hopefully now, hi, person in chat. Yeah, now when we're at the top, it's red. And if we loop it around, it should still turn red. I don't think that's working. I think I did something wrong. Maybe I need to do the mod before I do the absolute value. Yeah, that's kind of what I want to do, where I say if theta is more than 360, then set it to 0. Except, I think that if I change it like that, it might mess with the physics. It might make the physics not work. So I'm going to leave theta the way it is, but then try to compute what it would be. So if we say 361 mod 360, it'll loop back to 1. 365 loops back to 5. I don't know what negatives do, though. I don't know if I have like negative 370. That gives me positive 350, which is not good. Yeah, that's a problem. What happens if I do mod 180? Yeah, that doesn't work either. Okay, so this is already, we have an issue here. We got to figure out what to do about this. See, I feel like if I take the absolute value first, it should work, but, well, but it's not working. Why would this not work, actually? This really seems like it should, but I don't think it is. Like, there it turns red, so that works. That's good. But if it loops around again, I think it's not going to work if I loop it around this way. Yeah, it only does it when it's on the right side. Yeah, if it's on the left like that, then it doesn't turn red, even though it should. Whereas as soon as it gets to the right, then it turns red. It's like on the right, it's red, on the left, it's not. And that's bad. That's not what we want. So, that means we have some thinking to do. So we have, I wonder if I can draw. Maybe this will help me. Yeah, we got some figuring out to do. Let's see. So here's I'm going to make like a little number line, right? So here's my number line. When we're at 0, then what happens? Well, so here's 0. And if the angle is close to 0, then we want it to turn red. So we want, let's see. We want it to be red kind of in this area, close to 0, right? And we also want it to be red when you're close to negative 360, or when you're close to positive 360. Or you can keep going like negative 720, positive 720, those kind of things. And so the question is, how do we detect when a number is, oh, this is negative. How do we detect when a number is close to one of these points? And my mod thing isn't really working the way that I thought it would. So, yeah, we want to be close to here, or close to here, or close to here. So how are we going to do this? Because, okay, if I take, yeah, this is weird. If I take the absolute value and then do mod 360, this will make it so we only have to deal with positives. So it's like we're cutting off, here, can I like, we're only looking at the positive bit, like 0 and beyond. And actually, we're only looking at, so when we do mod 360, basically then we only have to care about this region right here. That if we can get it right in that area, then we're good. So this is what we do then. We say if it's less than 45 or it's more than 315, then it'll work. Okay, I think this is right. So if it's less than 45 or it's greater than 315, I think that's right. I think that's going to work. So we say if that is less than 45 or that is more than 315. All right, I hope this works. I hope this works. Let's see. Okay, good. 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 That seems like it's working. Good. Okay, what if we loop it around in the other direction? So far, so good. 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 We'll do one more. Good. Okay. I think the red is working. Now, my other thought is I probably want it to happen if you're pointing upward at all. So I actually think 360 minus 90 is 270. I actually think we want it like this. So if you're at all in the upper half, then it's red. And if you're in the lower half, then it's blue. I don't know. I don't think I'm going to stick with the red and blue coloring. I think I'll change it. But that's the idea, is you're trying to make it stay red for as long as possible. Like you want it to stay in the upper half as long as possible. I think that's a good goal. Okay. So I just realized there's a much easier way I could be doing this. Because I can just calculate the actual y position of the... Like I can just say, yeah, wait, why am I not doing this? I say if the sine of the angle is positive. Wait, I should have been doing this the whole time. I think this will do the exact same thing as what I was just doing. Oh, do we have cosine and sine switched around? We do cosine as positive? Yeah, because it's different than math. Oh, look at that. Look at that improvement right there. That is awesome. I love when you can shrink code. Shrinking code is the best thing. All right, we're deleting all that, which is awesome. Look at how much simpler that is. Just if the cosine of theta is greater than 0, because the cosine basically tells you if you moved one step in the direction theta, well, in Scratch it tells you what would your y position be as a result. And so if when you move in the direction of theta you have a positive y, yeah, okay, beautiful. Sine and cosine are weird to talk about because it's kind of different in Scratch than it is in math, but yeah, this is excellent. Okay, so now the question is, what do we want to make it look like visually when you're in the top half, like when you're winning at this game? Actually, you know what? Let's not do the visuals yet. Let's do a timer. Let's start with a timer. So let's say, yeah, we want a timer that checks how long you've been winning for. So let's see. We'll just call this timer, I guess. I don't know if that's the right name for it, but let's try it. So we have the timer, and we'll say, actually, this is pretty straightforward. We just say, if you're winning, so if you're currently balancing it correctly, then increase the timer. Change timer by 1. The color should fade to red depending on how close it is to 0. That's actually kind of clever. Yeah, that's kind of clever. I don't know if I'm going to stick with the red and blue. Like I might, instead of changing the pendulum color, I might change the entire background color. I think that might be cooler, but we can definitely play around with the different like sort of effects and stuff. Okay, this is not perfect, but it'll give us a start anyway. So my timer counts up and basically gives me points while I'm in the red, but then it resets back to 0 as soon as I hit blue again. Yeah. I think the other thing I want to do is keep track of your high score. Like what's your best? Because obviously I don't like that it resets to 0 immediately because you want to be able to see what your score was. So I think maybe instead of timer, I'll actually call it score. I think that's a better name. And then we'll make high score that keeps track of your best ever. So we'll say when the green flag is clicked, set the high score to 0. And then we'll say, could reuse code for the background pendulum fade if it's the variable. Yeah. Okay. So then we'll say, let's see, how do we set our high score? Well, if your current score is more than the high score, then the high score needs to be updated. So if your current score is greater than the high score, then we need to update the high score like that. And we'll put that here. Okay. And I'll put high score over here. All right, let's try this. So now Your score. Yeah, look at that. The high score stays at whatever your high score is. It doesn't reset when you lose. Okay, this is really cool. So now I'm going to try actually balancing once. Try actually playing the game and see what kind of score I can get. Okay, here's my balanced pendulum. I'm balancing, I'm balancing, I'm balancing. My high score is going up. My score is going up. Ah! Oh, I lost it. 360. Okay, that's really cool. I think that's 6 seconds. No, that's 12 seconds. All right, that's cool. That's really cool. One of the things that I don't like is that you can drive off the edge of the screen, like off the right side and same off the left side. So I think one of the things we should do is make it so that you can't do that. I think there should be a limit on how far you can drive. So I think what we'll do is say, if your X position, the X position of the cart, is greater than some amount, maybe 200 is the maximum, then we say, well, it can't be more than 200. So set your X to 200. But then we also want to say set your speed to be, your horizontal speed to be 0 as well, I think is how we want it to work. So now, all right, now I'm going to try driving into the right wall, and we'll see what happens. Okay, I think that worked really well. Actually, we should probably set x double prime as well. That's the acceleration. I'm not 100% sure on that, but I think that's probably the move. Chink! Yeah. I think that's good. So if I try to drive into the right wall, it stops me. Yeah. Oh, wait, no. Here's some weird physics. If I hold the right arrow, look at the pendulum is not doing what you would expect it to do, because the cart isn't moving. But the fact that I'm holding the right arrow makes it think that it's moving, and so then the pendulum kind of swings backward. Ooh, invert the velocity so it bounces. Wait, that's actually really smart. Oh, you're totally right on that. Okay, that's actually genius. That's a really good idea. So we take the velocity and we multiply it by negative 0.5 maybe. Yeah, that's really smart. Oh, you know what though? That might not... I think... Okay, my problem here is that... Actually, I think the acceleration is what I need to mess with. Okay. You're totally right. I have to figure out though how to make this work so that the pendulum, because we can make the cart bounce, but then we also have to make the pendulum react to the fact that the cart bounced, which is, well, it's not easy. Let's see. Here's what we'll do. We'll say, don't worry about setting the X. Just set this to be the amount over 200 that we are. Oh, except negative. So it's 200 minus this. That feels... it might work. Let's try it. Let's just try this and see what happens. Okay, what happens when I slam into the wall? It kind of bounces. Yeah. Oh, you know why? You know why it bounces? I kind of love it, actually. I kind of love it, like, springs off. That's really cool, actually. It's like a rubber band effect. Whoa. Okay, what if we make this 180? I did not intend for it to be a rubber banding effect, but, like, maybe it's kind of good. Look at that bounce. That's so much fun. Okay. I don't know if that's the right choice for the game or not. That kind of is so cool. Like, it kind of is awesome. It's definitely not what I thought was going to happen, because I forgot to account for the fact that we're dividing by 30. But, like, I kind of love it. Here, let's multiply by 30 once. This is what I thought I was going to do, where it's like an immediate bounce instead of a rubber band. And we'll see how that looks. Immediate bounce. I mean, yeah, that's basically what I thought it would be. It definitely works. Like, it definitely does bounce immediately. And the pendulum does respond in sort of interesting ways. You know, like you can... Okay, what if I'm balancing it and I hit the wall like this? Okay. That is cool, but I kind of like the rubber band, you know? I kind of like the thing where it... Like, maybe we'll say... Maybe we'll do a rubber band, but less extreme, where it's like kind of a smooth... Chink! Oh, that's not that smooth. Maybe like that. I kind of love that. Bouncy walls. Wow, you can really get the pendulum swinging fast if you... I don't know how to use this intentionally, but... Okay, we should do the left side too, because the left side right now you can still drive off the edge. So I think I'll just duplicate this. I might be able to like combine it into one if statement, but it's probably simpler to just do this. Negative 180 minus x. Yeah, that's right. Hey, the person says hi in chat. Okay. I don't think that's right. Oh wait, I need to be less than negative 180. Okay, that fixes it. Look at that, it kind of bounces back and forth. So if you get it going fast. I can't get it going as fast as it was going there, though. This was really fun. I do like that. Okay, and then when it slows down, you can see it's doing the bouncing. I love whoever it was in chat. Mr. Slithers recommended the bounce. That was a really good idea. If you need to compact the code, you could do an OR block. Yeah, I totally agree with you on that. We could compact it down. I think it's best to just make it simple, though, even if it uses more blocks. Make the code simple to read. Okay, we should probably have, like, visual boundaries. Like right now, it bounces, but I almost want like some physical barrier there on screen so you can see that it's gonna bounce. Like what if we actually made rubber bands that you could like see, you know? That you like run into the rubber bands and then it bounces you. I think we should try that. I have no idea if it'll work, but... or if it'll be cool. But I think we should give it a shot. Okay, I don't even know how we would do this, though, to be honest. I guess the first thing we would do is we'd go to an x of 180, because that's where our boundary is, and draw a little pen line. I remember you from the early days of 2.0. Yeah, I've been around for a while now. Apparently you have, too. All right, pen down, go to here, pen up. Make it negative. Okay. But then we want it to be rubber band color. What color is a rubber band? Kind of an orangey, something like that. Maybe paler? I don't know. Set the pen size. Isn't this your second live stream? It is. This is my second one now. You remember 1.4? Yeah, me too. The old days. You joined Scratch in 2013. Wait. Oh, yeah, okay. This is a good thing to realize. The cart bounces when the center of the cart passes 180, but we need to draw the rubber bands to the right of that. How wide is my cart? So my cart is 15 wide, but it has a pen size of 20, which is a radius of 10. So 10 plus 15 is 25. 180 plus 25 is 205. I think that's where it needs to be. So now That's our rubber band spot. Cool project. Thank you. Okay, so now we kind of want to draw the rubber band, like, you know, flexing. When you hit the rubber band, it should stretch to the right and then sort of bounce you back. So, how are we going to do that? Like, that's actually kind of a challenge. I don't know how to make the rubber band stretch that way. I guess one thing we can do is just go to an intermediate position. This is not really going to be good enough, but we can start with going to x plus 25. Wait, I just realized this is going to be very wonky. Yeah. So, so there the rubber band kind of stretches out to meet the end of the cart. 2 coordinates to draw between. Yeah, I think you're right that we don't want it to be like this V shape. 2 coordinates is actually kind of a smart plan. But obviously, so one of the things is we don't want it to stretch back to the left. So we want to say, thank you, Cool Scratcher. We want, how are we going to do this? I guess we're going to say, we can just do an if-else, honestly. We can say, if the x of the cart is greater than 180, then do this. Otherwise, just go to 205. Whoop! That's really fun. Look at that. And boop! I don't know why I find that so funny. But you just boop right into the thing and it turns you right around. It still is pointing, which is bad, but like, that's really fun. Okay, someone said 2 points. I think that's a good idea. I think we should try 2 points. So, actually, if the cart isn't there, we can just draw a straight line. So we don't even need the else here. We just only go to the intermediate points if it's necessary. Otherwise, just go straight to the bottom. And then we'll do y of 10 and y of negative 10, maybe? Let's see what this looks like. Okay, well, you can see what I was going for. It's not perfect, but now we have sort of 2 points that move. Yeah. Boop. Really, what we should be doing is not making it be separate points, but make it actually like a smooth curve. But I don't really know how to do that. I'm sure we could like physics it out, but it sounds complicated. Also, if we really wanted to be accurate, probably we would make the rubber band like vibrate a little after the cart leaves, that it would like actually move to the left just a touch and then back again. But maybe that's too much. Maybe I'm overthinking it. Let's see. What if I just change these Y positions slightly to be towards the middle more? Like I wonder if we can get away with a relatively simple system, or if we have to like really program in a bunch of sine and cosine and stuff. Because you know I'm willing to bust out the trigonometry if it's needed. But if we can do it a simpler way, that would be nice. All right, what does this look like? That actually doesn't look terrible. Yeah. Oh, okay. Yeah, it kind of sucks in towards the left. That makes sense, though. Yeah. This is not too bad, really. Like, this is pretty acceptable. It just is, when you get close at a slow speed, it sort of turns into like this zigzag, which I think we can fix pretty easily. Really what I want what I want is a math block that lets me get the minimum of 2 numbers. Like get the smaller of 2 values. Is there like a smart math way to do that? To like out of 2 numbers pick the smaller one? Decrease and increase a spring variable by its inverse until it gets to 0 and draw the curve according to that maybe. Decrease and increase a spring variable by its inverse. Oh, like, yeah, you're talking about like actual spring physics. And that would be, so we could use spring physics to do the rubber band. Only the middle point if it's just in the rubber band. Exactly, Jonathan. That's exactly what I'm thinking. That's exactly what I'm thinking. Actually, that's actually a smart way of programming it too. Yeah, that was a good insight, Jonathan. All right, so we're going to say if it's greater than 180. Oh wait, this is the reverse of this is the reverse of what I want. We want to say like this. This is kind of getting big and chunky, but maybe that's all right. So I think it needs to be 183, is like the cart needs to be that far to the right in order for us to draw those intermediate points. Otherwise, we'll do what Jonathan said and just draw 1. All right, let's see if we can avoid the zigzag this time. Oh. Did that work? Wait, okay, so that actually is working. So if the cart is moving slow, that breaks at some point. I don't know why. Oh, because I put 8 instead of -8. Or I put, yeah, there. Okay, this is good. Jonathan, your idea worked. So if it's just in the rubber band, then we only do the middle point. But if it's farther in, then we do we do 3 points. Yeah, that's good. Okay, I'm pretty happy with that. I'm pretty happy with that as the barrier. Wow, it just balanced my pendulum for me. That's cool. Boop. You can get it going really fast. If you time it so that the pendulum is up at the top and moving to the right when it hits the rubber band, it kind of works out perfectly to like make it really go. Yeah, I wonder if you can get it to like stop too. I don't know. Okay, should we do the left side? Let's do the left side. Let's add a left rubber band. I think that's a good idea. So, did we already do the physics for the left? I think we did. Yeah, so the physics for the left are already there. It already bounces. But we need to draw the rubber band. So, we'll basically just do this again. We can keep the same pen size and color. So much code. All right, we're going up. Going up. Okay. So now we're going to say if the x, we just have to basically flip everything around to be negative numbers. So if the x is less than -180, and then less than -183, the spring thing is working out pretty nicely. I agree. This turned out better than I expected. I wasn't planning on any of this. Like, I expected it to just be a hard bounce. Actually, no. It was one of you who originally recommended bouncing at all. I was originally going to just do, sorry, I can't talk and code at the same time. I was originally just going to have it stop when it hit the wall, but this is so much better. Okay, so there's that. And then we have to do -205 and -205. And I think that should work. I think that should be it. So let's try it. There's my left spring. Okay, that works pretty well. And then what about if we hit it just a little bit? Does it do the 1 point? Yeah, it just bends 1 point out. But if you hit it hard, then 2 points start to bend. There is kind of a weird like moment when it switches from doing 1 to doing 2, but honestly, I think it's pretty rare that you would actually see that while you're playing, so I'm okay with it. Yeah. It's not totally realistic, like right. Yeah, it's not 100% realistic, but I'm okay with this. I think this is good. These springs are so much fun. Mario, you're back. We added some rubber bands while you were gone, with help from a bunch of recommendations from people in chat. We got these rubber bands are so fun. I can't get over how much better this is now that the rubber bands are here. Okay, this is really cool. I think what we should do next is have a better visualization, like a better indication of when you're winning, like when the pendulum is up top. I think we should have a better way of showing that. Oh, by the way, I never talked about what these variables do. These variables, this one lets you change the length of the pendulum, which is kind of funny. It's actually interesting. This is kind of unintuitive to me, but a long pendulum is actually easier to keep balanced than a short pendulum. Although it's harder to get it up. Like it wants to just stay down. But once it is up, then it's easier to keep it balanced. Whereas a short pendulum, it's easy to get it spinning. Like you can get it up real easy. But then it wants to just spin around, and it's really hard to balance. So this, you can change the length of the pendulum. Here, this one, you can change the mass of the ball, like how heavy is the ball at the end. And this changes the mass of the cart, which you can't see, but if you make the mass really small, then the ball will kind of swing the cart around, which is pretty weird. What happens when you stretch the bands to be at the edges of the screen? I'm not totally sure what you mean by that. You can't stretch them far enough that they hit the edge of the screen. Although even if you could, I don't think anything weird would happen. I don't know if that's what you were asking or not, but look at that. Sometimes it just, the pendulum balances itself. Like I'm not even trying, and then it just does it. But then you still have to do some work to keep it balanced. I love too, our score thing is still working. You know what would be cool is if you got bonus points for hitting. Hey, new person here. Hello. Instead of being short, they hit the top and bottom. Oh, so like if you extend out the, yeah, I see what you're saying. So you could make them go, here, we'll just do the right side one. You could make them go all the way up to the top and the bottom. Yeah. Oh, that works too, yeah. Yeah. Now our 3-point system is actually kind of weird. now that we've made it go all the way to the top and bottom. Maybe we should take a vote. Maybe it's better with them stretched out like that. I don't know though. I do kind of like the look of just the little one because you can really see it stretching. It does work. Yeah, it totally works. So we can choose. We can choose what we want. I think my vote is still for the one on the left, the shorter one. Although I agree, like physically, it doesn't really make sense for it to just be floating there. So maybe we need some kind of... It looks better stretched out? Okay. Well, maybe we can vote in chat what people think looks better. Do you like a big stretched out rubber band or a small one? I vote stretchy. Okay. We can get a couple more votes in. Everyone who's watching, do you prefer the stretched out rubber band or the small one? Okay, Mario says it looks like the ball goes through the stretched one. That does make sense. Put some dots at the end of the short one. We could try that. All right, I'm going to try that right now. I'll put some dots at the end of the short one. Now we got votes for small coming in. Let's try some dots at the end of the small. Maybe that's what makes it better. How are we gonna, what's the best way of doing this? What pen size even are these things? 4? Okay. Is that the best way to make a dot? Yeah, that makes a dot. Maybe the ball should bounce as well. The Yeah, I don't actually know how to make the ball bounce, to be honest. the way the physics from Wikipedia work, there's only really one force that I can control, and it's the speed that you apply to the cart. So I'm sure it's possible, but I don't actually know the physics to make the ball bounce. So I don't think that that will work, even though it's a cool idea for the game. Okay, I'm making my little dots on the end of the... That's kind of big. I'm making my dots. I don't know if... I don't know if the dots should be the same color as the rubber band itself, or if they should be a different color. We can maybe take a vote on that as well. Or if we go no dots. Kind of like the dots. I think maybe smaller dots, but with a different color. Separate sprite that looked like the ball. It could change the variable for the pen. So we can definitely, like right now we're drawing everything with pen, but we don't have to. We definitely could draw things using sprites, and that would work fine. I don't know if that's what you're saying or not, but that is an option, just so everyone is aware. We had a separate sprite that looked like the ball. It could change the variable for the pen. Okay. I don't know how I feel about these dots. I think maybe we should try dots that are a different color. So I'm going to grab this color. Actually, you know what I'm going to do is instead of doing this all in here, let's just draw the dots separately. Is it possible to make the side ropes into some sort of hoop or a goal? That's interesting. I don't know about... Okay, this is this is actually a cool idea. I think the answer to your question is no, but we could add some kind of game element where once you get it balanced, so it's like you earn points for having it balanced, right? But someone who gets really good at balancing might get bored while playing this game. So it's like, what if then we added some targets for them to hit or something, where it's like if you can not only balance the pendulum, but also kind of move it around to the left and to the right, that you earn points for that as well. I feel like that could be cool. Have the player try and hit a certain point. Yeah. Actually, one of the things we could do, so that's kind of what I was thinking, Jonathan. We could also, if we wanted, reward the player for bouncing off of a rubber band on the side. It's kind of, actually, I feel like kind of difficult if you hit the rubber band. I feel like then it's difficult to keep balancing. Hit stuff and balance, like we said. Like, as soon as you hit the rubber band, it kind of knocks the pendulum off. But you could try to reward people for using the rubber bands. I don't know. I'd have to actually practice doing it because it's like pretty difficult, but that could be cool. I'm still figuring out drawing these dots here. We gotta come up with, maybe I'll actually do this color. What if it is scrolling? It actually wouldn't be that hard. It wouldn't be that difficult to make this scroll, but I kind of like having edges of the screen because I think it makes the game more difficult, actually. Like, I think it adds some challenge to it if you have to kind of keep it in the center of the screen. Thank you, Jonathan. I'm so glad you're doing more Scratch stuff. I actually am too. I'm having a good time with this. Okay, here's what dots look like if they're a different color. So if the rubber band dots, I don't know. I still don't know exactly what these things are, but maybe they like represent little pins or something, keeping it in place. Maybe then we make them smaller if they're a different color. We could also make the rubber band just a little bit taller. Instead of having the thing holding up the ball be a normal square, you could give it a design or make it a meme like a $19 Fortnite card. I've never played Fortnite, so I don't understand that reference, but we could make things be cooler than just these shapes. Let's see. I think we should try. I think my final decision here is I think we should go with, on the left, the smaller rubber band. Although I definitely understand the appeal of the right. I think the person who said it's weird that the pendulum can go through the rubber band on the right, I think they had a good point. I like the shapes, fits the scratch feel. I do also feel like just sort of the geometric shapes, I like that it sort of shows people that this is just pen. I don't know why, but that's fun to me. The small rubber band, you could argue that, you know, the pendulum can also move through the small rubber band, which is true, but I think it's less common for that to happen, and so it doesn't look quite as weird. So I think we should go with small rubber band, but pick some nice looking dots or something. Oh, and also I think I am going to make the short rubber band a little bit taller though. Like not super tall, but maybe just up to 25 or 30. Like what if we do this and then just go negative and positive? Actually, I'm going to go positive and then negative. A little bit taller. What does that look like? I'm not actually sure that that's better. I thought that would be better, but now I'm not sure. Maybe it was better the way it was before. I guess we wouldn't have to do multiples of 5 either. Like we could do 23 or something. Even though it's kind of a weird number, it might be the thing that looks best. 23, negative 23, 23, negative 23. All right, I think I might be happy with that. That might be the way to go. Okay. I think let's stick with that for now. Maybe also change. Okay, I kind of like the darker. What if we made them like the rubber band color, but darker? Like if we did, actually I can color pick it, can't I? Like if we made the end dots be kind of this yellow, but then just darker. That's not as good as I thought it would be, honestly. Make the bands the same height as the cart. I actually, yeah, I get what you're saying. I kind of like them a little taller though. Okay, I disagree with my own decision here. I think that was a bad choice. Okay, maybe something where they're darker but then a little smaller even. 7? No, I think it needs to be an even number. Huh. Okay, well, I'm not totally decided on what this should be, but I think for now, let's just do what we have on the left, and maybe later we come back and change the design a little bit. But yeah, I think for now the best thing we can do is just make a choice and move on, and later come back to it and maybe make it better. Hello. Okay. Most of the rubber bands in my house are pink. Okay, that's actually a good... I never thought about the fact that you have different colored rubber bands. Let's see. So this right here is what I was thinking of. Whoops. I don't know why that happened. Sometimes when I use a computer, I feel like I'm 80 years old because stuff just happens and I don't know what's going on. Okay, this is the kind of rubber band I was thinking of, but maybe we want something different. We could try different colors. What if we did do a pink rubber band? That's not terrible. Then maybe you make the dots purple. That could be kind of nice. Yeah. Okay, I feel like it's a little saturated though. Something like that? All right, I'm still not totally sold, but it's good enough for now. Make a swing? I'm not totally sure what you mean. Sounds cool though. What if it's like rubber band packs where when the game starts it randomly picks from colors, so you could have random colored rubber bands? That could be kind of cool. I think for now we'll just stick with this. I think what I want to do, I think sometimes when I'm making creative decisions, I feel like I have to just take a break and move on to something else and then come back later. And that really helps me. So I'm thinking, take a break from the rubber bands. Let's just stick with them the way they are. And then maybe when we come back to it later, it'll be easier to make a good decision. What I want to do now is replace, right now the pendulum turns red when it's up top. And I want to change that. I want to make that something different. I think maybe first thing to try is just what if we had, hi Zachary, what if we just had a different colored background? Like if we just make the background turn slightly green or something. I don't know if this will be the best, but I think it's a good thing to try first, and we'll just go from here. So we can have two different backgrounds, white and green, and we say, okay, if you're currently winning, increase your score and also switch the backdrop to green. Otherwise, if you're not winning, switch it to white. So it's like you're winning and then you're not winning. You're winning and you're not winning. Winning, not winning. All right, Mario's leaving, coming back. Sounds good to me. All right. You know what I think I want is a little dotted line to basically represent, like, I'm going to get rid of the red, actually. A little dotted line to represent sort of how high the pendulum... Oh, that was a bad move. Let me finish my thought. I want a dotted line to represent how high the ball needs to be in order to earn points. Is it here? Yeah, okay. Is the score related to how high the pendulum is or just whether it's above half or not? Ooh, good question. Right now, it's just based on whether or not you're above the threshold. But we could do that, where it's like the higher the pendulum is, the more points you score. That's not a bad idea. It wouldn't be difficult to do either. Like, we could do it, no problem. We'd have to decide if that's what we want or not. Couldn't you go on to edit, restore blocks? I probably could have. You're probably right, actually. That would have been smarter. Didn't think of it. It's a good call, though. Okay, I wish there was an easy way to make a dotted line, because I really do want this line to be dotted, but I feel like it's going to be kind of a pain. I could make it using a different program and then import, but I don't know if that's any better. Like maybe 6. Okay. Actually, if we copy and paste, this shouldn't take too long. How are we going to do this, though? Do I go shift? Yeah, okay. Actually, I should memorize how many times I'm pressing the right arrow. Oh, also, I forget that when I press the shift key, it like... for some reason, it makes a really ugly sound. I'm just using my built-in microphone on my computer, but every time I press shift, here, listen to this. That's me pressing the shift key. I don't know why it's so bad, but I'll use right shift instead. Okay, so we'll go 1, 2, 3, 4, 5, 6, 7, 8. Maybe 8 is the number? Okay, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I think I counted wrong. I don't think that's right. Is there any friction with air? There is air resistance. I don't actually think that it's physically accurate. The physics that I found on Wikipedia were based on having no air resistance, and so I just kind of added a damping factor in myself. But it's not really based on real physics, so it was just kind of my best guess. It works well enough for the game that it's fine, but I think if you were trying to like accurately simulate physics, you would probably have to be more careful than I was. Okay, we made it to the other side. You know what? We made our dotted line, and it wasn't too painful. I think I am going to try to center it, though. Actually, I think I can center it perfectly. This thing where they snap to the center when you're editing a costume is relatively new, and I love it. Didn't used to exist, and it's great. I would just use pen and go repeat 10, pen down, move forward. Oh, yeah, wait, that's smart too. I could have drawn this with pen. Well, I did it now. But that's another good idea. Marcus here is full of good ideas that I wish I had thought of myself. Okay. And then here's what I'm thinking too, is maybe the green is only in the top half. Like maybe it only shows the green in the top half, because that's where all the winning happens, you know? Oh, and then I have to send it to the back. Okay. So it's like, ooh, you're winning, and then you're not. And then you're winning, and then you're not. Okay, it's still not perfect, but it's getting closer. I feel like it's getting better. Yeah. Oh, you know what would be cool? Is the score. So we have the score variable right now, but what it should do is we should draw the score in like big, bold letters. I think big green letters on top of the green background. I think that would be really cool. Makes the dotted line kind of hard to see though, you're right. What if we change the dotted line to be green? Am I... There. What if we made this green when you're in the winning setup? Not sure that it's better. What if there are two dotted line sprites and they create clones from either side? Make it more visual. I kind of like what you're onto here of like, what if the dotted line moved? Make it dark green? Okay, here's an idea. This combines a bunch of ideas that a bunch of people just had. What if... Okay, first of all, maybe the dotted line only exists. I'm going to get rid of this. What if the dotted line only exists when you're not winning? And then when you're winning, it just looks like this. Okay. Then... Here, I'm going to make a custom block called draw dotted line. I should probably actually split my whole render custom block into a bunch of them because it's like messy, but here's what I'm thinking is draw the dotted line with pen, like someone recommended, but then also what was I gonna do? Oh, make it disappear when you're winning. Okay. So actually we'll say only draw the dotted line if you're not winning. So if not, and then we have this thing down here that says you're winning. If you're not winning. Okay. Draw the dotted line. So I have a huge appreciation for people who can manage to translate Wikipedia equations into Scratch. I feel like not that long ago, I would not have been able to do this. It's only because of sort of the recent math classes that I've taken that I finally feel like I have an intuition for being able to do that. Which is why I recommend paying attention in math class, because you learn useful things. Okay, so we want to go to negative 240, and then we want to say repeat a bunch of times, I don't know exactly how many, change x. Yeah, I'm drawing the dotted line here. We'll go pen down and pen up. Actually, we'll do that. Okay. We'll go more than 10. Maybe we do that actually. Double pendulum? Yeah, no, not gonna happen. Not a chance. Not a double pendulum on a moving cart. Someone might be able to figure out how to do a double pendulum that doesn't move, that just sticks in one place. But not a moving double pendulum. Not gonna happen. At least not by me. Maybe someone a whole lot smarter than me can figure that one out, but 4, 3, 2. Okay, I think I'm gonna go with. I don't mind that actually. 15 and 15. That's pretty good, and then maybe a little lighter. Something like that. Okay. And then it becomes green, and then it becomes dotted and green, and dotted and green. That's pretty cool. Okay. What else am I? Oh, I was thinking I want to make the dotted line move. Yeah, I want to make the dotted line move. So I think we can actually just use the timer to make it like a smooth movement. So I think we just say -240, and then we subtract, I don't know, some amount. But we got to do it mod 30 so that it doesn't just move left forever. And we can just make this number be however fast we want it to move. So maybe we want it to move 15 pixels per second. 30? I don't know how I feel about the moving dotted line. It is pretty cool, actually. I think this one might grow on me. When I first saw the moving dotted line, I thought that's too much movement, like it's too complicated, but I don't know. It's kind of cool. The dots should converge onto the cart from either side. The dots should converge onto the cart from either side. Oh, like move in? Okay, here's actually an idea. Here's an idea. What if this is kind of a wild idea. What if instead of lines, they were triangles pointing upward to sort of indicate that you're supposed to go up? Oh wait. Oh wait, no, this is right. Like, okay, something like this, where it's arrows pointing up. I think they shouldn't be equilateral triangles. I think they should be 90-degree. Like they should be right triangles, actually. So we should say, oh, someone says yes, cool. All right. So we'll say, go to there, and then do that. So we say, I have to use a go-to block because I want it to move diagonally. So I can't use change x and change y, because then it would be all jagged. So we go x plus an amount and y plus an amount. You'll just have to bear with me for a second. So half of 15 is 7.5, but that's kind of weird. So what if instead of making these be 30 wide, we make them be 28? Yeah. So then we'll go plus 14, and again, x plus 14, and it'll be y plus 8. Actually, we can just do 8 and then 0. Oh, and by 8, I actually mean 7. That's weirder than I thought it would be. Do I mean 14? Yeah, I do mean 14. Oh, and also instead of mod 30, it needs to be mod 28. No? Oh, it needs... Oh, I made these way bigger than I was thinking. Okay, hang on. So let's go with 8, 8, 8, 16, 32. Okay. I think I want to also go back to the beginning. So x position minus 16. Actually, we'll just do change x by negative 16 and then by 32. Maybe that's not better. Maybe that's not better. What if it was one continuous zigzag that sort of points up? Okay, I have to make it longer. But one continuous upward zigzag. That's kind of cool. I kind of love it. Yeah, I kind of love it. Oh, but now, okay, the one thing is now it's not really pointing up. Like now it is, you know what I mean? It just is a zigzag. I kind of love the zigzag though. I kind of think the zigzag is too good to give up. We could also, and this is intense, but maybe instead of moving to the left, we could make it be like a wave that like it sort of moves up. Can you make spinning line? It's going to be harder. I don't know what that means. Okay, so what if we make this do the wave? So we say sine. Actually, let me pop into Desmos here because I am not exactly sure what I want. Do I want sine squared? I think that might actually be what I want. Yeah. So we'll say sine of 30 times timer squared. Does this go up to 1? Yeah. Times, say, 4. That doesn't work. Okay. First of all, it's way too slow. But then second of all, I forgot. They're all moving in unison, which isn't what I want. I'm back and this looks amazing. We're definitely making progress here. It's pretty cool. We're in a kind of a slow moment right now because I'm trying to make this zigzag look cool. And we're just trying different stuff. But okay, this is... Here, let me exaggerate it so you can see what I'm doing here. I'm trying to make it wave. I mean, we can do the wave. I don't think this is actually better. It is kind of fun, but I'm not sure that this is an improvement. We can make one arrow lift at a time, maybe? I don't know. I don't know, man. I think it maybe was best as just a zigzag that moved. All right, we'll keep these scripts around in case we want to go back to them, but maybe we just do this for now. Or maybe just this, honestly. I kind of like the movement. We'll go with 20. Okay, so once you're up, probably I want the zigzag to continue even when you switch to the background with green. Like, probably that should be a green zigzag then. Yeah. All right, well, I'm not going to do that right now because it seems like a lot of work. And I don't really know how to do it. I don't know what the best way is. But we'll come back to that idea of keeping the zigzag when you're up top. For now, I want to render your score when you're up top. Like I want to make a better way of showing the score than just this thing. So, in order to do it, let's see. We need numbers that we can actually display, so they have to be costumes. I think if it moves up and down instead of right and left, it would look... I don't know what that word is. Since it won't be moving against the line. I couldn't totally understand what that message meant, but if you want to try to rephrase it. Okay, so here's my idea, right? The idea is, oh, nicer. It'll look nicer since it won't be moving against the line. Yeah, I do kind of like the up and down. Oh, like we could do... Are you doing a pen score? It's going to be... Kind of, yeah. It'll probably use stamps. So yeah, I guess that is pen, technically. Yeah, okay, I think you're right, actually, about making the line move up and down. Like, what if we make the zigzag just move up and down a little bit? 7-segment LED type engine for it? Okay, that's basically what I want to do, but I think I just want to use regular vector numbers. It doesn't have to be like a 7-segment thing in order to draw any number. So, okay, I want to try the moving up and down thing though. So, what? Oh, that's a good question. Why do I have the same title for the stream? It's because I didn't think to edit it. All right, PullJosh's Pendulum live stream. Save. All right, I just tried to change the title. Let me know if it actually changed for you. Why is it not moving up and down? I feel like the zigzag should be moving up and down right now. Is it just really slow? What if we do 20? Oh, yeah, that's why. All right, I'm getting rid of this. It changed. Cool. Cool. Okay, 4 plus y. Oh, wait. Yeah, I want it to go up and down by 8, but then I want to subtract 4 from here. Okay, we'll make it wiggle faster though. Like maybe 500. Okay. There. It's got a little up and down wiggle to it. Yeah. All right. I'm not totally convinced of the up and down, but it's kind of cool. You know what? I should be doing these number costumes in the main sprite, actually. Yeah. So we're going to say 0. Make it big. And that's that. Now we got to decide on a color. Two lines and they moved up and down separately. That could be cool. You know what though? All right. I feel like for now, I want to just stick with a plain old zigzag. Every other arrow is moving up or down. That's kind of cool. Yeah. Although I want it to indicate upward movement. Yeah. Yeah, there's a lot of options there. I feel like I don't have it all figured out yet. All right, what about render score? And yeah, I'll actually make a little input for it. So we'll say render score. Oh, but we'll render score only if you're currently winning. So we'll turn this into an if else. So if you're winning, draw your score, otherwise draw the dotted line. And we'll plug in the score. Okay. So for render score, I just want to do some stamping. So we're going to say, for now, we're just going to say switch to costume 0 and stamp. Yeah, but we got to do it at a particular position. Okay, I actually think 80 is pretty good. Now I want, though, a scratcher live streaming? Impossible. They said it couldn't be done, and yet here we are. Oh, I can't pick that color green. I think I can pick it from here, though. All right, pick, and then fill. Except then I need it to be darker. All right. That's ugly. That's really ugly. What if we increase the saturation? That's closer. That's closer. Maybe not quite as dark. And like that. Okay. I'm pretty happy with that. Maybe go even subtler, though. Cool. I'm still trying to pick exactly what I want here. All right, we'll stick with that. Okay, then the number 1. Then 2. All my costumes are named wrong here. 3. Wait, how? I must have done something. Oh, okay. Wait, does it? Oh no, okay, that makes sense. Make the 0 as dark as the cart. Match the cart color. That's kind of interesting. Make it simpler to change colors with color effect. That's actually smart. That's a good idea. Seven, 8. Ooh, we're getting close. Last one, 9. I don't know what's happening. We're trying to make the score show up on the screen up top. Right now it just shows 0. So, okay. I'm going to make a variable n that's just going to be my counter. We're going to say set n to 1. And we're going to loop through all the letters, all the digits in the score. And then stamp them onto the screen. So we'll repeat length of score. Except actually I want to use this score here. Change n by 1. Switch costume to a particular letter of the score. Letter n of score. Okay, that's progress. And then we just need to set the position. So we need to say, what position do I want to be in, actually? I guess for now, let's just do something times n. We'll say go to the right 100 pixels for every n. Okay, except we want to do n minus 1 so that it starts from 0. Actually, what we want to do is n minus half the length of the string, I think. Maybe we also need to subtract 1 from that? I don't know. Yeah. This is actually really cool. Oh wait, minus a half. Oh, we'll do n. Wait, that's actually weird. N minus the length of score divided by 2, I guess? I don't really know how that works, but no, it's not right. So we'll say n minus a half. The physics looks sharp, thank you. Yeah, it literally is like Wikipedia physics, so it should work. Hey, look at that! Remove the project URL or someone might use Turbo Warp to steal the code. Dude, that sounds awesome. If someone steals the code, that sounds great. I hope they learned something. Okay, this is really cool. This is really cool. I want to get to 1,000. It's kind of distracting, to be honest. But maybe that's part of the game, is you got to ignore the distraction of the score counter. It's quite the balancing act. Okay, I'm going to try to get to 1,000. I think, to be honest, that I'm running out of energy right now, so I might stop the stream pretty soon. But this is really fun. Ugh, couldn't do it. Hey, look at that. We used the rubber band successfully. That's cool. Yeah, all right. I'm running out of energy, and I got to go to class soonish. So I think I'm going to stop for now. But this was really fun, and I'll consider doing another stream at one point. Is that in one sprite? Yes, it is. Just one sprite. All pen and stamping and all that. All right. Thanks for stopping by, everybody. This was really fun. Share it. I will keep working on this because I want to make it better. But I will share this project at some point. All right. And actually, yeah, seriously, if you want to like play it right now, you can use Turbo Warp or whatever with that URL. All right. See you later, everybody.